the first step is to factor. Any of these problems, you need to factor first. Our numerator is a quadratic, and it will factor into two binomials. Set these up. X squared breaks up into x and x. I think what two numbers multiply to get -2, but add to get a +1? Well, 2 is prime, so it's either 2 and 1, -2, +1, -1, +2. The middle sign will always tell you the sign of the larger number. So this is going to be x plus 2, x minus 1. The middle sign always has to go with the larger number. If you haven't figured that out with factoring, process that. Take that in. So then we take x minus 3, and I see if anything will cancel. If a factor cancels, that means we have a whole. Nothing cancels, which means there is no whole in this function, because nothing cancels. Our x-intercepts are when we set our numerator equal to 0 and solve. So I've already factored, so it's going to be a lot easier if I just take these factors and set them equal to 0. So I take x plus 2, set that equal to 0, and x minus 1, set that factor equal to 0. And I solve. So I have an intercept at x equals -2 and x equals +1. As ordered pairs, because we're going to be graphing, this is -2, 0, and this is 1, 0. These will be the points that I will plot on my graph below. I'll do all of that in just a minute. My y-intercept is when I place zeros for all the x's. So I'm basically covering up all these x's. What I'll be left with are my constants, -2 over -3. You could work with the factored form, but I think it's going to create a little bit more work for you. So f at 0 is 0 squared plus 0 minus 2 over 0 minus 3. You do not have to show all of this work. This is going to be a +2 over 3. So our y-intercept is at, when x is at 0, y is at 2/3. Vertical asymptotes, we set our denominator equal to 0 and solve. So see where d of x equals 0. Remember, vertical asymptotes directly link to your domain. Our denominator cannot equal 0, otherwise it's undefined. So our vertical asymptote is at the line x equals 3. That's where we will have a vertical break in our graph. Horizontal asymptotes. There are two scenarios where you have a horizontal asymptote. Either the degree of the numerator is less than the degree of the denominator, or the degree of the numerator is equal to the degree of the denominator. Those are the two different scenarios. Are either one of those true in this case? No. We will not have any horizontal asymptotes because our degree of our numerator is 2 and the degree of our denominator is 1. 2 is greater than 1 by exactly 1 degree. So even though I don't have any horizontal asymptotes, I might have a slant asymptote. A slant asymptote is also given the name oblique. A lot of texts will call it an oblique asymptote. Future math teachers might call it that also. Whose music's turned up so loud? Can you turn that down, please? Now, how do we find this slant or oblique asymptote? What we have to do, and if you look in your brochure, this was step 6. Step 6 tells us we have to use either long division or synthetic division. We can use synthetic division because I have a square, a quadratic, divided by a linear. So I'm gonna put my work over here. Synthetic division. I look at my denominator, x minus 3, and I change the sign to a +3. Then I list my coefficients for the quadratic. 1, 1, negative 2. Bring down your leading coefficient. 1 times 3 is 3. In synthetic division, you multiply and then you add. So I add 1 and 3 is 4. Multiply and then add. When you are finding your oblique asymptote, you only have to look at the linear function. You do not have to think about your remainder. This linear function is 1x plus 4.
Wait, where?
That's fine.
Can you go over how you set that up again?
Yes. You look at your denominator, x minus 3. This is the factor we're dividing by. The possible root here would be a positive 3, okay? Which is why we put a 3 here, not a negative 3. You always change the sign in synthetic division. Then I take all the coefficients, and I have 1, 1, negative 2. And then I bring down my leading coefficient, I multiply, and I add, and repeat those steps. So my oblique asymptote is at y equals x plus 4. If we graph all of this, I'm going to put my asymptotes on here, and then I'll plot the points that I know. My vertical asymptote is at x equals 3. And then I have a slant at this line, 1x plus 4. That means I have a y-intercept at 4 and a slope of 1. So that's going to look like this. So these are the guides for my graph. But that's all I know. That's all I know from this. So let's look at what our intercepts were. We came up with a couple. I had x-intercepts at negative 2, 0. So that's one right here. And I had another intercept at 1. And then I had a y-intercept at 0 and 2/3, so somewhere in here. So this portion of my graph I can kind of start to see. If I connect these dots and follow my asymptotes, I get something like this. The table is used for you to find additional values. Take these x values, plug them in, and figure out what y is. Can someone tell me when they plugged negative 5 in, when they plugged f at negative 5, what they got for y? Yes?
Negative 2.25.
Which makes sense based on what we're seeing over here. What about when we plugged 4 in? Yes?
Negative 1 half. No, 1 half.
When you plugged 4 in?
Oh, 4 0.
Yeah, I'm skipping ahead.
18.
Yes?
Yeah.
Which again makes sense. 4 is going to be all the way over here and up in this little corner, which I kind of ran out of room. It's going to be up in this corner. So this table serves for you to be able to connect the dots for more points. It's not just this part of the graph. It's also, if we look here, this has this upper part. Rational functions most of the time will have a mirrored part. So we had, let me add in our slant asymptote. What was our slant asymptote?
X plus 4.
X plus 4.
I thought it was oblique.
It's the same thing. Oblique and slant means the same thing. So you see when I put in this slant, my graph starts to follow it. And then remember, I had a vertical at x equals 3, which is right there. Okay? 2 of your test questions, you will not have a calculator. So you're going to have to be able to create a table and connect the dots and sketch this graph
Wait, check her answer with the calculator?
without your calculator. No.
What if it's secret?